Here's Precalculus Concept video 2D, arithmetic sequences. We're going to use the formula for the sum of the first n terms of an arithmetic sequence. This is a really cool lesson. There's 3 boxes, so let's get into it right away. It says we're going to find the sum of a finite arithmetic sequence. First of all, something that is finite, right, means that it has an end, right? It has an end. So we're only talking about, let's say I want the first 30 terms of an arithmetic sequence, or the first 50 terms, or something, but it has to have an end. That's what the word finite means. So I'm going to give you the formula, and then in box 3 I'm going to show you how that formula works and why it works, okay? So let me give you the formula right now. So this is a very important box, so copy this down for me. So the S sub n, the S means that we're going to have the sum of the first n terms of an arithmetic sequence is going to be the number of terms you have over 2 multiplied by the very first term plus the very last term. So let's go over what each of these things is, okay? So this n right here means the sum of the first n terms. So we want the sum of the first n, however many you have, terms. Okay? So this n and that n, those numbers match up. Okay? This a sub 1 is the very first term that you have, the first term, and this a sub n over here is the very last term, that we have. So as long as you know the first term and the last term, you can figure out the entire sum of that finite arithmetic sequence. So this formula is very, very important. We're going to use it in this lesson. Okay, box number 2, here's an example. It says, find the sum of the first 40 terms of the following arithmetic sequence. Okay, so I want the sum of all this stuff. So I have 5, 7, 9. This is arithmetic, right? Because to get from the first term to the next term, I would add 2. To go from this term to that term, I would add 2. So it looks like I have a common difference of 2. So if I want to add this all the way up to the 40th term, I'm going to cut it off right here at the 40th term. So I have 5 and I have 7, that's 12. And then I have 12 and 9, that's already 21. So how much would this thing add to if I added up the first 40 terms? Okay, well, you might notice something. Well, I don't know what the 40th term is. And I need that for my formula because the formula of the sum of the first n terms is going to be n over 2, the very first term plus the very last term. So far, the sum of the first 40 terms is going to be 40 divided by 2. The very first term I know is the number 5, but I don't know what the last term is. So I need to use the fast forward formula in order to get it, and that's what we're going to have to do first, okay? So I want this. I want a sub 40. It's going to be a sub 1 plus the quantity of n minus 1 times d. We learned this in the previous lesson. So this is going to be 5 plus, this is going to be 39, and the difference happens to be the number 2. So this is going to be a value of 83. So now I know that the 40th term is a value of 83, and that's the number that I plug into this formula over here. So the sum of the first 40 terms is going to be 40 divided by 2, multiplied by 5 plus 83 is worth 88. All right, and then 40 times 88 all divided by 2, when you plug this all into the calculator, you should get 1,760. So make sure you plug that into the calculator and check and see that that's what you get, 1,760. So if I added up all these terms, the first 40 of them, I would guarantee to get the answer of the solution, 1,760. That's what that means to find the first number of terms of an arithmetic sequence. Okay, let's talk about how the formula works. I do think it's important to talk about this. Let's say for I wanted to add up the numbers from 1 to 100. 1 plus 2 plus 3 plus blah, 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 plus all the way to 97 plus 98 plus 99 plus 100. Let's say I wanted to add these all up, okay? Right now, how much do you think this is? Take a guess. Okay, now that you have your guess, let's try and figure it out. Well, what would happen if I wrote this sequence backwards, like this? What if I did 1 plus 2 plus 3 plus 4 plus all the way? This would have to be 99 plus 100, right? This one have to be plus 98 right here. This would be plus 97, and so on and so forth. Well, if I wrote it backwards and I added these up vertically, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. Are you guys noticing anything? All of these give you 101, right? Plus 101 all the way down the line. So how many of these do I have? Well, you have 100 101s, right? You have 100 101s. And you want to know the sum of just one of those, not both of them, so therefore you must divide by 2. Well, I could rewrite this as 100 over 2, and I could rewrite this as the very first term, 1, plus the very last term, which is 100. So hopefully you see that that mirrors that exactly, right? I want the sum of the first 100 terms divided by 2. There's the very first term, there's the last term. So when you plug this all into your calculator, you get an answer of 50, 50, 5,050. So hopefully you guys got that.